In this application, we're going to be looking at, well, I've got the Acuity AP820-80 model up mounted on a linear slide. And here, I'm not sure if you can see this, but here's the laser line. You can see the laser line right there. And of course, you can see it on the screen there. And with the AP820 model, typically this laser measures from about 2.4 inches out to 5.5 inches from the face of the laser. So it has an 80 millimeter depth of field, which is about 3 inches. And the laser line starts with a width at the near end of about 1.6 inches, and it goes out to about 2.2 inches at the far end. And here we're a little bit, we're about 25 millimeters into the near end of that measuring range. This sensor will have a linearity of about 1.7 thousandths, and excuse me, that's the resolution, 1.7 thousandths, and it should be accurate to plus or minus 1.9 thousandths. So in this application, what we're going to be doing is trying to measure a difficult surface of this dark composite material. And here you can see when I put that laser line in between them, let's zoom this up. Here you can see the first thing you're going to see is we're not getting any spurious node signals. Looks very clean at the edges to measure that width. So we should be doing a really good job on that. And as I, of course, move it over the different targets, there's a little piece of a second layer put on there. And you can actually see that pretty easily, that change in height of that second piece of tape, if you want to consider it as a tape. And of course, as we zoom that up, this is roughly 2 millimeters or about 80 thousandths. And we're picking up that edge pretty good on those different surfaces as we move it. You can see that edge moving across there pretty easily. And this is the -80 model. So let's zoom this back out, and so part of the application is to measure the width of this material, and then also do what I consider flaw detection, which is to see if we can see any upturned edges. So to give you a quick idea, and also it'll show you the capability of this sensor to measure on a real difficult target. I mean, this is a stainless steel brushed veneer caliper, and I've got it set at 1 inch. And so here we can see that gap. And with our Acuity View software, we do have some tools built in, and this comes with each laser. So if we were to put it on the two edges there, and then we're going to look at the features, and we're going to do on feature 1, here's feature 1, you can see the little box. We want to go to the right most pixel. And then feature 2, we're going to go to the left pixel. And if we come in here and we click on the little results screen, so we're looking at this distance as being 25.3712 millimeters. It's really about 25.4. So we're approximately 20 microns or half a thousandths off, and that could just be simply from my alignment here, right? As you see, as I change that alignment, it changes that measure. Well, let me get it back into the feature boxes up here. So as I'm in these, let me increase the size of this feature box. So now when a little bit bigger. So now when I move it in and out, you can see that it's measuring that measurement here, 25.43, very accurately. So just sort of a real quick check to show you the accuracy and how easy it is to make that line measurement, that gap measurement or width of this material. And if we if we moved our boxes, we could also make that width measurement of this material. So real quickly, what that's showing is that we are getting a really good signature going from the wood to the dark, and we went, of course, on from dark to a metalled surface. So here you can see we're going from that brushed stainless steel plate to the dark surface, and here's that interface. You can see that we're getting really clear edge detection and signal on some difficult targets. So that's one of the big advantages of the Acuity AP820 is its capability to make very clean measurements on difficult targets. So let's come back and look at this material. And also with the Acuity View software, we have we actually have a little linear slide with an encoder, and the linear slide probably is not that calibrated at this point, but typically with some really good motion control, you're basically going to collect the Z data points, and the way this sensor works is it puts out 290 odd pixels, then it interlaces and scans and puts 290 even pixels. So what that does is it gives you 580 points in the Z direction and the X direction, and the linear slide is going to give you Y positions. So you can see that changing on the screen. And so with this program, we've got a little 3D measurement capability. So let's go into the 3D. Let's go ahead and clear that. And what we're going to show is as I scan across this target, and let me just build up some data points. Put that in, let's clear it again. So we're going to do a live data point scan, and here you'll see it build that 3D model up. And of course, this is not, like I say, this is not the best mechanics. But as we have this data, so there's that surface, and it may be hard to see on this video, but you can see that we're picking up the individual pieces of tape right there. So very visible on this, and of course, it doesn't have the best color control to be able to see those small 5,000 or 6,000 changes. But as you can see from this, we are getting very good data on that scan. And I think the AP820 should do a very good job on it. And let's just look at the static lines there. That gives you a better idea of the resolution. So you can see the different patchworks and pieces, and here you can see there's a little tab that's up. So just a quick example of how easy, and like I say, there should be very little filtering needed on the AP820. And so my only suggestion is whether we go with the -80 or the -120. And of course, the -80 has a smaller line width, but if you put it out at the far end, it'll be about 2 inches, whereas the -120 will be getting a 3-inch line, and it still meets your requirement. We'll still be accurate to plus or minus 3 thousandths.